Welcome to the first video on the channel and to the first devlog of this yet to be titled RPG. On screen you see my little test area that we will be running around in for the foreseeable future. As you might have guessed from the player sprite, the game will be vaguely in the style of Octopath Traveler, games I'm very obsessed with. This first iteration here is basically a one-to-one copy of the Octopath sprite style. We'll see how it will evolve. The rest of the assets you see are from the amazing Kenny. Of course, all just placeholders. Since this is the first devlog, let's do a quick run through of the basic structure I'm using for the game. As many of you might have recognized, it is developed with Godot. I started with a beta version of Godot 4.5 and will try to keep it up to date to the next versions. The test level you see inherits from a level base scene with nothing in it except the player and a bit of lighting. And the test level itself is, as I said, full of placeholders. The level geometry is a single static body with a dozen collision shapes attached to it. And there isn't much else to see, except the interactable objects, which we will come to in a bit. But first, a quick word about the player character. It is a box standard character body 3D with a sphere collider and a billboarded sprite for the visuals. Concretely, it is Y billboarded, so the sprite is always upright with respect to the world coordinates. Setting it just to enable would point it fully at a camera. Other important settings: shaded has to be on for lighting to affect the sprite, and alpha cut has to be enabled for the sprite to cast shadows in the world. And of course we have to set the texture filter to nearest to get nice crisp pixels. The movement code for the player character is what you would expect and what you would see in any tutorial on the topic. First we read the player input. At the moment I only have WASD and arrow keys, but this should work for gamepads too. Second, if there is input, we transform it to be relative to the camera. Note that we have to set the Y coordinate of the basis vectors to 0 before normalizing them. This allows us to move parallel to the ground plane. Let me know in the comments if you would like to see a video on all the math that's going on here. Third, we add the Y component of the current velocity to preserve vertical movement, which allows us to add gravity. Only a tiny amount at the moment. I want the player character to stick to slopes, but if gravity is too high, the character will slow down on slopes quite significantly. And I don't know yet whether I want the player to be able to jump off ledges, so we'll revisit the gravity topic a few times, I imagine. What might interest some of you: I tried to get the code for this character controller from Perplexity AI. It did the extraction of the camera basis vector correctly, which was nice to see, but made quite a few mistakes overall so that the code wasn't functional. In particular, it put the velocity vector as an input into the move and slide function. Probably because that's the way it worked in Godot 3, and there's much more text about that in the training data of the LLMs. So, while my advice on the use of LLM chatbots for code generation would normally be to only use it for common boilerplate code, I cannot even recommend it for that anymore. Zooming out on the game systems, I currently have 3 autoloads. An event bus inspired by Peterson's talk at GodotCon 2025, link in the description. A game manager, which isn't doing much right now except holding placeholders for an inventory and player stats, but this is where, for example, saving and loading will go. And then there's an autoload for all scenes I want to preload, which is inspired by a video by Queble. And that's the basic structure so far. Now let's go into the interactable components, which is the most interesting topic, I hope. In an adventure setting like in this game, there are many interactions, all of which have a similar overall behavior. You go somewhere and maybe press a button, then something happens, then you go somewhere else, and often you want several things to happen in succession. Depicting a message, receiving an item, showing an animation, triggering a battle sequence, etc. Depending on how you combine them, you get the behavior of a treasure chest, an NPC that gives you an item during dialogue, or a cutscene that ends in a boss battle. And the easiest way for me to think about these interactions is to have a single type of object that handles all the high-level management steps for how such an interaction works and looks like. I call it an interactable component. We can drag it into a level and simply specify the general behavior via these export variables. Most importantly, I can choose from an enum to decide how it is triggered by the player. Simply by entering an attached area 3D, by pressing an interaction button, or not at all. The latter is used when other interactions trigger it. I can also choose what happens after the interaction is done. Nothing, deactivate the interaction, delete the interaction, or delete the parent. Deactivating the interaction is useful for, say, a resource that gets replenished after a certain amount of time. Deleting the parent happens when you pick up an item or defeat an enemy, for example. Quite a lot of power and responsibility to be able to delete the parent, but that's fine. Deleting only the interaction itself is something that happens with, say, a treasure chest. You want the chest to still exist in the world, but not be interacted with anymore. Lastly, I can also specify a follow-up interaction by simply dragging another interactable component into this nodePath export variable. There's also a way to check if the player has certain items in the inventory, but I'm not satisfied with how that works yet. Now let's have a quick look at the script for this scene. The important stuff is handled by the functions start interaction and finish interaction. Firstly, they send out signals which are sent to the event bus and then onward to the game manager. This way we can let nodes with more authority handle things in case we want to trigger something big in the game. Apart from that, these functions toggle the running flag so that each interaction knows whether it is currently running and should be doing something. Start interaction doesn't do more, and finish interaction does the expected 2 steps. Trigger the follow-up interaction if one exists, and handling the finishing process that is specified in the respective export variable. All the actual stuff that an interaction is doing should then be implemented in the start and finish functions of a scene that inherits from this one here. Before we look at that, the rest of the interactable component script. Signals of the attached area 3D check if the player character is close enough and starts the interaction if necessary. But if the interaction is supposed to start when the player presses a specific button, we check for that in unhandled input. So completely ordinary checks for player interaction here. Next, let's look at the 4 interactions I derived from this. First, the item collect component, used for pickups and similar things. It has export variables for which item to drop and the quantity. And it immediately finishes the interaction after starting because the game manager deals with updating the inventory. Just as simple as the puppeteer component, which is my silly name for an interaction that starts an animation on an animation player somewhere in the level. Imagine anything from a door opening to full cutscenes playing out. I also have a component that starts a battle. I'm using a separate battle scene that gets added as a child here. For now, the battle scene gets a message handed to from the interactable component. In the future, this will be a dictionary of things like which enemies should appear, which background art and music to use, whether it is a tutorial battle, and whether appropriate hints need to be displayed. Stuff like that. The last interactable component I have is the message component, and it's the only one where there's actual work done inside the component. The node itself has a canvas layer as a child, which contains a speech bubble, which in this prototype is just a color rect and a text label. In the process function, I animate the text by updating the visible ratio of the label. In unhandled input, I check for a press on the input button and either fully show the text or finish the interaction. Together, this gives the typical behavior of text boxes in games. At the moment, the message component can display a single string specified by an export variable. Since I can concatenate interactable components, it would be possible to create longer dialogue sequences with this, but I will probably use Nathan Hoad's dialogue manager and create a dedicated interactable component that uses it. In the future, I might add other interactable components, for example for triggering shop dialogues or minigames, or if we are thinking explicitly about Octopath Traveler again, something like the path actions would get their own component. For now, however, these 4 should be enough to have some basic things to do while running around in the world. Next, I want to do some light scaffolding. A main menu, a simple save load system, and scene transitions. Stuff that will make testing various ideas and systems easier, maybe adding controller support. And only after that I will tackle the battle system. Thank you for watching, and until next time.